ABM School of Engineering, Department of Mechatronics Engineering, online classes, subject analog devices and circuits, unit number 1. Okay, hi everyone. So last class we discussed with different power supply and a different rectification and the filter process. So in this class, we are going to discuss about the amplifiers, that is feedback and power amplifiers. Okay, so that means we are going to take some part of the output as a reference voltage for the feedback process. Okay, so when the circuit is open loop, that means it will not be more reliability. So we go for the feedback. So we are getting some reference from the output. So we are analyzed, then we are produced the output. This is the basic concept of feedback amplifier. So the process by which a fraction of output energy is injected back to the input is called feedback. The amplifier using these techniques are called feedback amplifiers. So what are the characteristics of basic amplifiers? That is important characteristics of an amplifier is voltage gain, input impedance, output impedance, and the bandwidth. Okay, so when design amplifiers, we have to consider these parameters. Okay, for a good amplifier, the voltage you gain will be very high. So input impedance very high, output impedance very low, and a variety of bandwidth. That is maximum bandwidth you have to fix for the amplifiers. So what is the need of feedback? The parameters of a basic amplifiers are required to change as per the need. So these changes can be brought out efficiently by introducing the feedback in the amplifier. That means we are going to vary the different gains. In open loop, if you are giving some input, you will get some output. Okay, that will be changing this concept. There are two types of feedback. Depending on the effect of feedback signal, there are two types. One is negative feedback, another one is positive feedback. What is negative feedback? So when the feedback signal decreases the net input signal, that is, the feedback signal is 180-degree out of phase with respect to the input signal. It is called negative or degenerative feedback. So positive feedback. So when the feedback signal increases the net input signal with respect to the feedback signal is in phase with the input signal. It is called a positive or regenerative feedback. So what is the advantage of negative feedback? That is improves stability in gain, reduces distortion, reduces the noise level at the output. Advantage of negative feedback, that is increase the gain, decrease the distortion, decrease the noise. What are the advantage of positive feedback? That is increase the distortion, increase the noise, poor stability. So comparison of positive and negative feedback. So this is a basic principle of feedback. So that is we are taking the output from some part, then we are given to the input with the different models. That is feedback amplifier is one which the part of the output of amplifier is fed back to the input. It consists of basic amplifier with the gain E, feedback network, sampling network, and the mixing network. The basic amplifier, the stage simply amplifies the signal that is present at its input. The voltage gain of this amplifier is A. So that is the voltage gain of these amplifiers A. So feedback network, it is a usually basic two-port network which may contains resistor, capacitor, and inductors. So this is a sampling model. That is sampled signal is voltage, sampled signal is current. Mixing network. that is series feedback and shunt feedback. So series feedback means we are giving current, that is shunt feedback means we are giving voltage. Advantage of negative feedback amplifier, that is stability, less distortion and high fidelity. Disadvantage of negative feedback, reduces the gain of an amplifier. So basic classification of the negative feedback amplifiers, that is voltage series feedback amplifier, current series feedback, current shunt, voltage shunt. So that means how we are taking the output feedback and how we have feed the input. So that is defines. Okay, this voltage series feedback amplifier, that is we are taking the voltage. We are taking the voltage and we are giving to the series. So series means current, that is always connected with the inline. But shunt means it will parallel as well as voltage. So next one is current series, that is we are taking as a current and we are giving to the series. Current shunt and feedback. So current shunt, இங்க நம்ம என்ன பண்றோம்? Shunt. Okay, this is the voltage shunt, that is we are taking as a voltage and we are giving as a shunt connection. So these are the different feedback models. So next one is power amplifier. So in small signal amplifiers, the main factors are amplification, linearity and gain. Since large signal or power amplifiers handle relatively large voltage signals and current levels, the main factors are efficiency, maximum power capability, impedance matching to the output device. So there are three power amplifiers available. One is class A, class B and class AB. The amplifiers conducts through the full 360 degree of the input. The Q point is set in the near middle of the load line. The amplifier conducts through 180 degree of the input. The Q point is set at the cutoff point. And class AB, this is a compromise between the class A and class B amplifiers. The amplifier conducts somewhere between 180 to 360. The Q point is located between the midpoint and the cutoff. Then class C and class D, the class A amplifier conducts less than 180. The Q point located between the cutoff level. Class D, this is an amplifier that is biased efficiently for digital signals. So this is the model of class A amplifier, class B amplifier, class AB, class C and amplifier efficiency. That is operating cycle 360. AB means 180 degree to 360. B means 180. That is C means less than 180. And D means pulse operation. So same as power efficiency of the different. Here power efficiency refers to the ratio of output to input power. The lower the amount of conduction of amplifier, the higher the efficiency. Okay, so this is the concept of feedback and the power amplifier. So most of the circuit use the negative feedback because the reason of we can control the output gain. Okay, we are not required more gain, but we require different variable gains. So we need a negative feedback as well as for high power transmission, high power process, we need a power amplifier in the different models. That is class A, class B, class AB and C and D. Okay. Okay, thank you. So next class we will see the oscillators. How to oscillate the signals, that is how to generate the signals like that we will discuss in this next class. Thank you.